Hey guys, welcome back to my channel. Today we are going to solve a problem, third problem from the Geeks for Geeks weekly coding context 158. Guys, observe this question. I already uploaded the videos of these two problems in my channel. Uh, Contest. This is a 158 rated contest. Guys, I am going to the problem. Guys, you read the question along with me, so you will understand and write the important points in the question on the paper, so you will understand more better. So now it's Bob's turn to meet Elias. Bob's and Elias are best friends who live in a city represented as a graph with n nodes and m bidirectional edges. Here main point is bidirectional edges. The Bob starts at the one node 1 while Elias resides at the node n. Bob is eager to meet Elias, but Elias has set a unique condition for the meeting. Bob can only travel the Elias if his path does not contain any three consecutive nodes that are increasing odd numbers. Here main problem with the this is actually BF. This problem is, we can, if we not mention this condition here, so specifically I will tell you later that what is. So Bob's path must not include a sequence like 357 7 level 13. However, these all are the increasing odd number, three consecutive odd number which are increasing means 3 is greater lesser than 5, 5 is lesser than 7, so they are increasing and they are odd numbers. So the sequence may contain like this, 753 353. These are all odd numbers, but they are not increasing. Here these are all odd numbers, but they are not increasing. This is also odd number, but they are not increasing. The two odd numbers are increasing, but one is even number. So these all are allowed, but these type of conditions are not allowed in the path, since it does not consist of three consecutive increasing odd numbers. Since it does not consist of three consecutive increasing odd numbers, Bob can travel one node to another node directly connected to in exactly 1 second. He can travel one node to another node in exactly 1 second. You are tasked to help determine Bob minimum time in seconds required to reach Alice. Here, guys, remember one thing. He asked minimum time, and he is asking it is the graph problem. So our thought should go to that breadth first search, BFS. BFS algorithm gives the level of the particular node. The level of the particular node in a BFS algorithm gives us minimum distance. Okay, guys, here observe. Required to reach Alice at node. If it is not possible for Bob to reach Alice under the given condition, return -1. If it is not possible the Bob under given condition, we have to return -1. Guys, here let's take these test cases. I will explain you what actually is question in given, and then so guys, uh, initially Bob is at node 1. He has to meet node n. Okay, there are some condition, so he does not supposed to go three consecutive increasing odd numbers, 3 5 7 or 23 31 49. Consecutive odd numbers means their difference should not be not like that. They have more difference, but they are they are in uh, their odd numbers comes one by one and they should increasing. So that type of path does not, we should not follow. Okay, guys, here 357 these are allowed, but these are not allowed, sorry. But 356 353 these path are allowed. These are not consecutive, because here on an even number, here one is here these are not increasing, so this type of paths are allowed. Okay. Okay, guys, here what he is saying is, uh, uh, so we have to meet. Guys, here he asked us to find the minimum distance. So let's take the graph what he given, 1 comma 3. Let's take this graph. Uh, uh, 1 3 5 2. Here 4 is there. 4 is not connected, so he can go from here to here, but he can't go from here to here, because 1 comma 3 comma 5 are consecutive increasing odd numbers. Okay, now he can go 3 to 2, then he can come back, because here the edge is bidirectional. Okay, the edge is bidirectional edge. Okay guys, now he can come back, and here for moving one step, here we get 1 second, and it is for going to each step 1 second, again he is coming back, then again 1 second. Now he can go to this 5. So he said he has only n nodes. So if 5 is our target node, 5 is our target node, is a source, this is a starting node, is a 5. So we reached it, it is in, we reached it is in how much time, how much time, 4 seconds. Okay, 4 seconds. Okay guys, here one thing you should, for suppose if 2 is not there, what he given, suppose he given only 137 and it is 5. So we never reach, because if you go like this and we come back, this is also 3 consecutive paths, and if we go like this is also consecutive paths. Here let's suppose the target is 7, because 1 to 7 nodes are there and remaining nodes are not connected, remaining nodes are single, like this, assume like that. So we never reach 7 here. So guys, this is, you should remember. Here he asked the bidirectional, he asked the find a minimum time. So guys, here remember always, remember always that when he asked us to find minimum distance, minimum distance between two nodes, then we have to prefer the BFS only. Here also we are performing the BFS algorithm only, breadth first search algorithm, but with some condition. In this path we can at most take 0 consecutive odd nodes, 1 consecutive odd nodes, 2 consecutive odd nodes, 3 are not allowed, 3 consecutive odd nodes are allowed. This is only if you apply if you take care of this path only, if you take care of this condition, then our problem is very simple problem. Okay guys, here what I am doing is, here first I am converting that vector, I am taking one adjacency list, adj of n plus n, adj of n plus, why I am taking n plus 1 here means, here our nodes are starting with 1 to n. So we have to take care of, we have to take n plus 1. We are neglecting here zeroth node we are not considering. So guys, here I am taking one auto, here edge, right, and from I am taking edges. Okay, here guys, edges. Okay, now adj of edge of 0 dot push back edge of 1. Okay, now I am, this is a bidirectional graph, right? So I am taking both sides. I hope this basics, I think you know. Here we are not entered till now actual problem is comes in front is there. So guys, here edge, this is where I am making one adjacency list. Now what I am doing is, I am taking one Q data structure. In Q data structure, what I am storing is here we have to here we are doing the same BFS algorithm. In BFS, what we do some Q data structure, we take care of some visited array. Here Q data structure with, we have to take that consecutive odd nodes, we have to take care of that condition only. Consecutive odd counts, consecutive odd counts. Remaining problem is same as BFS only. We have to take care of consecutive odd, increasing odd nodes should less than or equal to 2. So guys, here what I am taking is, I am taking the Q data structure with the node, and here what I am taking is, here I am taking consecutive odd nodes. How many consecutive odd nodes are consecutive odd nodes? And I am taking level. The level of graph is our answer, right? Timer, for example, here the level of graph, for suppose with this condition, if we reach some point, means that is our actual level of graphs. The level, here we are taking the level. So guys, here you will understand, I am declaring one Q data structure. Q data structure. Q pair of first is integer node. Second, in second pair, this second pair, uh, here guys observe, in second pair, uh, int comma int, now q. Okay, now what I am doing is I am starting with node 1, right? I am starting with node 1. Okay, I am starting with node 1. How many consecutive odd number, including that we have to take care of, including that how many consecutive odd numbers are there, how many consecutive odd numbers are there. We are starting with 1, right? Consecutive odd number count is 1 and level of 1 is 0. We are at 0th level. Okay, now guys, here what I am doing is, here q dot push is equal to, here observe, q dot push is equal to one node. Second node is how many consecutive odd numbers. Third is its level. Okay, third is its level. Okay, it is at 0th second. So I am taking the level of the n. I am finding the level of n by this condition. I am finding the level of last number by this. If we reach there, if it is, for suppose, if your graph is like that, like this, 1 3 4 and 2, but our target nodes is here, we can't reach here. So in such cases I have to return -1. I have to return -1. Okay, now guys observe, here this is the level of that node. This is consecutive odd number counts, and this is that node, particular node. Now guys, I am taking one visitor array, same as BFS, breadth first search algorithm, but here with little modification. I have to take care of uh, visited array. Then visited array, we have to take care of one vector of 3 comma 0. Okay, here I am taking size up to 3 because we can take 0 consecutive odd counts, 1 consecutive odd counts, 2 counts. At most we can take 2 only. If we given 4 consecutive odd counts, in such cases I have to take care of 4 here. In this problem he mentioned at most 3 consecutive, at most 2 consecutive. Node does not contain any 3 consecutive increasing odd number, means it can contain up to 2 consecutive odd numbers. Okay guys, here for one node, how many I am storing the visited array of, current node is 1. I will do the dry run of this problem later. 1, observe. So guys, here no, I will explain with dry run now, so you will understand the code better later. So guys, here I am clearing this board. 1 comma 3 comma, here 2 comma, it is 5. Okay, here it is 4. Okay, here it is 4. Okay, now guys, from one child I am moving to this. How many consecutive odd numbers here? 1. Okay, consecutive odd numbers, this is all visited. We have the one graph, right? Like here I have the one graph. It contains 3 nodes. It is 0 to 1 node, and here it is 0 1 2 0 1 2. Sorry, this is, let's clear this board. Here this is 0, it is 1, it is 2. Let's suppose it is 0 node. Here I have to take care of 1. We have 5 nodes here. We have 5 nodes, 1 3 2 5. Here we have 4. 4 is not connected, right? So 0 0 1 2 0, it is 0th node. 0 1 2 1 2 3 4 5. 1 2 3 4 5, right? So I am starting with 1. So in first cases we have consecutive, we have node is odd, and we have consecutive, including this is this is 1, right? We have to take care of, this is the odd number, right? We have to take care of this odd number also. Present consecutive odd number is how much? So I have to take care of 1. So 1. So I am making that, this is all are initially they are marked with 1. 1 is visited. Now I am going to this. Now I am going to this 3. 3 comma consecutive odd number count is how much? Now consecutive odd number count is 2. 3 comma 2. So 3 comma 2. 3 comma 2. Here I am making this is a visited. Now guys, I can go from 3 to it's all his child, right? Let's take this is we can go from here to here. We can go from here to here. We can go to here. I am checking this. I am checking this. Now guys, consecutive odd this second part is increasing consecutive odd numbers. If I go here, increasing consecutive odd numbers, how much? It become 1 again, because 1, then 3, again 1. These all are not increasing. Increasing consecutive count becomes here again 1. So 1, we are reaching the child 1, and increasing consecutive count is 1. So guys, it is already visited. Here 131, 131. If it is, let's take this here. Now from 3 we can go to this. Increasing consecutive count is how much? 3. 1, 3. Increasing consecutive count is 135. 3 comma 3. Increasing 3. We reached 5. Increasing consecutive count is 3. So we never go this side. We never go this side. We never go back side also, because 131 increasing consecutive count, when we reach here is it become 1, because here it is increasing, again it is decreasing, here it is increasing, again it is decreasing. So guys, here we never reach here, because this path is already visited. This one node with one increasing consecutive number, so that path is already visited. Okay guys. Okay, now we never go to its parent also. So okay, now I'm going to the 2 node. Now 2 node, how many increasing consecutive odd counts? Here increasing consecutive odd count, it becomes 0. Why? Because 1 3 2 here up to 1 comma 1, here 3 comma 2. When we reach 2 comma 0, when we reach 2, 2 is a child, and 2 comma 0, because increasing, it is a even number. Right? It is a even number. So increasing odd count is 2. So guys, here when we are going to, we can't go this side, we can't go this side, we only go 2 side. So increasing, so now child is 2 and child is 2, it is visited. Now I am making this is as a visited. Okay guys, video length becomes length become much lengther, but I am explaining the dry run, so it become lengther. Guys, be patient and listen, so you will understand more deeper. So guys, here now 3 comma 2. Okay, 3 comma 2 increasing odd count. Now observe guys, here from 2 I can go only 3. We don't have any child. When we are going to 2, 3 comma 1, increasing I am reaching the child 3 and increasing odd count. We have only 1, because 3 comma 1. 3 comma 1 is where? Here. 3 comma 1 is here. 3 comma 1. 3 comma 1 is not visited, so we can go here. Now 3 comma 1 is good. So again it is decreasing, right? It is decreasing. So we can't take this side. We can go, and when we go, this is also visited, we can't go its parent. Now we have only this part. So when we come here, 5 increasing odd count is 2. When we come here, 5 increasing odd count to 2. And again parallelly we are taking the level of this node, right? So level of that node, we have to take care of that node also. 5 comma 2 means it is a visited array, so we are taking in queue the level of this node parallelly, so we will get our answer. Guys, take this test case and try your own, so you will understand much better. Okay, 5 comma 2, we are not supposed to go. If you go back from 3 to, if you go back, what happened? Consecutive counts are 0 and 2. That is already visited. We are not go. This is also visited. This is only not visited. 5 comma increasing odd count is 2. 5 comma 2 is not visited. So we are making this is as a visited, and we reach the final node. Okay, as like that I am performing this operation. You guys try your own this algorithm and take this test case and try your own, so you will understand more better. Okay guys, I am doing the coding part now. Here while q dot size is not equal to 0. Q dot size is not equal to 0. I am taking the first element, pair of int comma int pay is equal to q dot front q dot front. Now guys, I am making q dot pop. I am making q dot pop. Here I am making the removing the first element. So I am taking the parent. Now first p dot first is what? It is a node, right? P dot first is, it is a node. It is a node. P dot sorry, right? It is a parent, right? Let's take it as a parent. Okay, it is a node. Let's take it as a parent. So it is a p dot first. Okay, p dot first. Next odd count. Now next is odd count. Let's take it as a previous odd count. No, parent odd count. Parent odd count. Parent odd count is equal to p dot second dot first. P dot second dot first. Now guys, int I am taking level of that node. Level of that node, that is a minimum level. Level of that node is a is our answer, because in level or in BFS the shortest path is level of that node. Level of that node is p dot second. Okay, p dot second. Now guys, here I am auto child adjoint of parent. Okay, adjoint of parent. Now guys, what I am doing here is, observe here, I have to calculate if child is a odd. I have to calculate how many. Now present odd count. Let's take it as 0. If child is a odd number, and child is greater than parent, then child is a odd number and child is greater than parent. Now guys, present odd count. Present odd count is equal to parent odd count plus 1. Okay, present odd count is equal to parent odd count plus 1. Okay guys, parent odd count plus 1. Now else, if child is a even, if child is odd, then we have to take care of child is odd. If child is lesser than parent, like this case, if child is lesser than, means 131, if you reach here 131, now present odd count becomes how much? It is 1, right? Present odd count becomes 1. So guys, here if it is a odd, if it is even, it is 0. Initially we have 0, right? No need of calculate that. For in the case of even, child percentage modulo 2 is equal to if it is a odd number, then present odd count is equal to 1. Okay, now guys, here this is we have to take care. If present odd count is less than or equal to, at most we can 2 only. At most we can take 2, and that is not visited, that child is not visited. We have to take care of child comma and present odd count is equal to 0, means that is not visited. If it is not visited, then I have to make that is we have to come inside and child comma present odd count is equal to 1. Present odd count is equal to 1, and I have to push that element child and present odd count. Present odd count I have to push in the queue. Present odd count and level, now it is child, right? Parent level plus 1. I have to take care of that, guys. And when we reach, if here observe, if parent is equal to n, if we reach the last node, then I have to return that level. Else I have to come totally outside. I am returning false. Guys, I am submitting this code. Here I got the wrong answer. Here the push spelling is wrong. Again I got the wrong answer. Logic is same. Here q dot push. Here one more bracket I have to include here, right? This is pair of pair. Yeah, for sample test case I got the correct answer. Guys, this is just a simply BFS algorithm with that condition. That's enough. Yeah, it's submitted successfully. If you have any doubts, please ask me in the comments, and please do subscribe my channel, guys. Thank you.